Hello, everyone, and welcome to today's webinar on one of our newest camera releases, the Forge 1GigE SWIR. My name is Manisha Sherbakova, and I'm a sales engineer here at Teledyne IAS. In today's webinar, I will go into an introduction into SWIR technology, why it could be interesting for your application, and how it works. I will then dive into the features of the new Forge 1GigE SWIR. Teledyne IAS, or Integrated Imaging Solutions, is under the parent company of Teledyne. Here at Teledyne, we have the slogan of everywhere you look, because our portfolio covers a very wide range of products that can be found all around you. Our technology can be found in everyday objects like your cell phone, medical scanners, cameras, all the way up to the International Space Station. Teledyne's wide product portfolio can be split into four main divisions: digital imaging, instrumentation, aerospace, and engineered systems. Our group, Teledyne IAS, falls under the digital imaging division. This group is responsible for products ranging from sensors, cameras, image processors, and software, all the way to X-ray and RF systems, LiDAR, GIS, and many other imaging components. Teledyne IAS initially started out as a small team of UBC graduates here in Vancouver who came together to form Point Grey Research back in 1997. Eventually, Point Grey was purchased by FLIR and FLIR purchased by Teledyne. Our team has a very long history of being leaders in the machine vision space. So what is SWIR? As you may already know, the electromagnetic spectrum spans a very wide range of wavelengths. Visible light spans in the range of 390 to 760 nanometers and is the light and colors that we see with our human eyes. Infrared rays have a larger wavelength and span from larger than 760 nanometers all the way to 1 millimeter in wavelength. Within this range, we have shortwave infrared, which is from 760 to around 2000 nanometers. From 2000 to 4000 nanometers is the medium wave infrared, and larger than that, all the way to 1 millimeter wavelength, is long wave infrared. Long wave and medium wave IR are IR rays that are emitted by the object itself based on its temperature. SWIR works similarly to visible light in the sense that these waves are reflected or absorbed by an object depending on its material properties. Therefore, different materials show up differently under SWIR light, allowing us to differentiate between them, even if they look the same under visible light. I will show you some examples of this in the coming slides. When it comes to sources of SWIR light, ambient starlight and night glow are natural emitters of SWIR, and typically artificial SWIR emitters are used for certain applications. In the following pictures, I have assembled some sample images of objects under visible and SWIR light. In the first image, we have some coffee beans mixed in with different types of rocks. As you can see, even though most of the rocks are a similar shade of brown, in the SWIR image, they all show up differently because their materials absorb and transmit SWIR rays differently. The second set of images is various types of transparent plastic. In the visible light image, it is almost impossible to see any objects because they are all transparent. In the SWIR image, on the other hand, you can see some bits of material, and some objects are black. These bits of plastic are made of silica gel. This is a great example of how different types of plastic can show up differently under SWIR. On the bottom, We have some pasta that is mixed in with pieces of plastic that are the same color. Under visible light, it is difficult to differentiate between them because they are the same color, but as you can see in the image on the right, the pasta noodles absorb SWIR light and show up very dark, while the plastic simply transmits the SWIR. These types of situations are great examples of SWIR being used in food sorting. Typically, impurities like rock, plastic, debris, etc. have different SWIR properties than the food item itself. So SWIR cameras are used to detect and sort them. Another interesting example of SWIR is analyzing paintings. On the left here, we have The Last Judgment by John Provost. When imaged under SWIR light, the painting tells a different story. You can see that during the process of painting, the artist intended to have many more trumpets. Some of the trumpets were positioned in a way that required the sailboat to be moved. You can also see that the feet were not originally positioned the same way they are in the final image. Another example here is Bountiful Fruit by Philadelphia artist Nicole Koenitzer. Under SWIR light, we can see the planning process that went into the image. We can see in the initial sketch that the artist intended to have a picture frame in the background with an image of another fruit basket with bananas in it. You can also see in the foreground that there were some paint specks. These insights into the original painting give us a glimpse into history, and it is made possible due to SWIR imaging. The main principle of SWIR imaging is the fact that different materials behave differently when struck with SWIR light rays. Some materials absorb SWIR light and will hence show up dark in the image, while some transmit it and will show up lighter. As you can see in the graph, silicon wafers transmit SWIR rays in the range of 1100 to 1550 nanometers. This property is the reason why SWIR cameras are often used for silicon wafer inspection, as the wafer shows up almost transparent, and you can easily detect defects. Water absorbs SWIR light in the range of 1400 to 1550 nanometers, and is hence used in fruit sorting. Typically, fruits on a conveyor belt are sorted for bruising. An area on the apple that is under the surface may have signs of bruising that are not visible to the human eye. SWIR cameras can help capture these bruises, allowing the sorting of fruit by quality. TEC stands for thermoelectric cooling. It's a solid-state device that transfers heat from one end to the other when electrical energy is applied, and this is called the Peltier effect. These types of devices are often used for cooling cameras. They are rated according to the amount of heat that they can transfer. Some applications, for example, biomedical or pharmaceutical applications, where you need really long exposure times and high sensitivity, require cameras to be cooled in order to reduce the noise as much as possible. Some SWIR cameras are cooled in order to make sure that the images can be as clear and noise-free as possible if you are using extremely long exposure times. There's a benefit to having cooled cameras or uncooled cameras, depending on what your settings are, what your application is, what your budget is as well. Because typically, these cooled cameras are expensive and make your overall setup very bulky. Within our portfolio, Teledyne Princeton Instruments has a very large portfolio of cooled cameras. SWIR cameras that are uncooled or techless operate at regular ambient temperatures with minimal passive cooling. They are more compact and lightweight and are much more power efficient. They do have slightly higher noise levels and dark current compared to a tech camera, but they are suitable for a very wide range of applications depending on the settings. These cameras are versatile and are used in a broader range of applications, for example, industrial inspection, food sorting, medical imaging, agriculture, and security. They are often chosen because they are very easy to use, easy to maintain, low cost, and are very portable and smaller in size. They are typically best used for applications that require shorter exposure times. They are also a lot more cost effective. Before you decide to incorporate SWIR imaging into your machine vision application, there are certain questions that you must ask yourself to understand how to best fit this camera to your needs. The first question you must ask yourself is, of course, what is your application? What are the materials you are trying to image, and how do they behave under SWIR light? If you are trying to detect one material more clearly than the other, you need to know how it behaves with SWIR lighting to know if it will show up clearly in the image. The second question is, how long of an exposure will you need to see your image clearly? This will depend on a lot of things, like your light source, your ambient light, etc. The longer exposure you choose to have, the more likely you are to have infrared noise in the image. To reduce this noise while still having a high exposure, you might have to consider getting a cooled camera. What pixel size and resolution would you need to get a clear image of your scene? What is the working environment for your application? Do you have any ambient SWIR light, or would you need to get a SWIR emitter? Is it a high temperature setting? The SWIR camera heats up that will cause some amount of noise in the image, so that is something to keep in mind. And last but not least, what is your cost budget for the camera? All of these questions are important to ask when planning a SWIR addition to your vision setup. And here I present to you our brand new Forge 1GigE SWIR camera. This uses Sony's new cutting-edge InGaAs sensor in a compact form factor. It is a SWIR sensor, which stands for visible SWIR, and can capture images in both the visible and SWIR spectrum with the wavelength range of 400 to 1700 nanometers. It is a high-resolution 1.3 megapixel sensor and has a small pixel size. It is a compact industrial-grade design and it's 40 by 40 by 44 millimeters. It provides an ideal balance of performance, size, and GigE reliability. So why would you want to use the Forge 1GigE SWIR? This camera can identify and differentiate materials by their unique spectral signatures and detect moisture, chemical composition, and thermal properties with high precision. It has improved visibility in very challenging conditions. This camera provides superior image clarity and contrast in low light, fog, and through certain opaque materials. It makes it ideal for applications that are set in hot and steamy environments, hazy outdoor conditions, and in medical diagnostics. This camera has gone through non-destructive testing and quality control, so it allows for the inspection of internal structures without damaging the object. This is crucial for industrial quality control and food sorting. It has many flexible applications with the inclusion of narrowband filters. The use of these filters for specific wavelengths can enhance material detection and condition monitoring. This can be critical for many applications such as agriculture, food production, recycling, research, and industrial inspection. This camera has many useful on-camera features, such as pixel correction, a sequencer, and logic blocks. The factory pixel correction allows for improved image quality. You can correct pixel defects and create images that have much better quality. The sequencer enables targeted inspection of individual areas in a sequence, optimizing the inspection process for specific regions of interest. The logic block allows for precise control over image capture with triggering, synchronization, and output signals to several peripheral devices and light sources. Here are the preliminary product specifications for this camera. As you can see from the graph on the right, this camera has a very high quantum efficiency in the SWIR range. Some of the standout specifications are the frame rate, for example, that can go up to as high as 93 frames per second, which is faster than some of the competitors. This camera, as I mentioned, uses the Sony Sen-SWIR IMX990 sensor and is a global shutter camera. The pixel size is quite large at 5 micrometers. The camera's operating specs are from around -20 degrees Celsius to 65. This camera is a 1 gigabit Ethernet camera and has several GPIO options. So why would you want to choose to work with Teledyne IIS cameras? Our cameras come with a world-class customer support system with a generous warranty and extended life cycle. The forged 1GigE SWIR has been tested for superior heat dissipation, and the internal electronics of the camera are designed in such a way that the heat dissipation is taken away from the sensor to allow for the heat and the noise to not affect the quality of the images. The camera is designed in a way that it is easy to mount in your setup, and it is engineered for exceptional quality and performance. Teledyne IIS is proud to be one source and unlimited vision. The forged 1GigE camera is compatible with the Spinnaker SDK, which you may be familiar with if you've used our other machine vision cameras. It has many comprehensive tools for image acquisition. We also have the Separa processing software that has many advanced image processing capabilities. Because our camera is GennyCam and GigiVision compliant, it is also compatible with several third-party applications, allowing for easy integration into your existing system. When it comes to SWIR imaging, lenses and filters are extremely important. Our partner, Edmund Optics, offers many different lens assemblies designed with glasses that are optimized for performance in the SWIR spectrum. There's a very wide range of lenses and filters available on the Edmund Optics website. This brings us to the end of the webinar. Thank you so much for attending, and if you have any questions, please feel free to drop them in the Q&A box. I hope to see you guys again in our upcoming webinars. Thank you.